All right, so we've got the sum of the second and the third terms of a geometric progression is equal to 84. And the second term is 16 less than the first term. Given that all the terms in the progression are positive, find the first term. All right, so you'll notice how they reference the second term twice. That's interesting. So the first thing I'm thinking about is they talk about the sum of a geometric sequence. So I write the formula down, thinking maybe something can plug in there. And I need the first term, I don't have that. I need the common ratio, I don't have that. Between the second and the two terms, I guess I could do something with this, but the problem is I really need to find the R. In order to do that, I need to know A and the sum, and I don't know A. So let's raw this out and take a look at it. The second term, that's X. And if I want to get to the third term, I'm going to multiply it by R. So the third term is going to be X times R. All right, that's 1. So let's write an equation for that. X plus times R is equal to 84. They gave us that information. And see, now I'm thinking that they've given me two pieces of information, and so maybe we're dealing with a system of equations. So let's take a look at the second term. The second term, which we're calling X, equals 16 less than the first term. Well, the first term is just X divided by R, so I can write it like this. So let's try getting X by itself, because that's what we got to find, the second term, I think. And when I do, I can factor out the X, and it looks like this. X is equal to 84 over 1 plus R. So if I can get the other side to equal X, well, I can make them equal to each other, and then I can find out what R is. So let's do that. If I subtract X over R on both sides, now keep in mind, X over R, that's the same thing as saying negative 1 over R times X. So if I factor out the X, it's going to be 1 minus 1 over R is equal to negative 16. And so if I get the X by itself, I just divide by 1 minus 1 over R. All right, so I got both of my pieces of information equal to X. So now what I can do is I can make what they're equal to each other. So that would mean 84 over 1 plus R is equal to negative 16 over 1 minus 1 over R. Now I got two fractions equal to each other, so I'm just probably going to cross multiply, and that's going to be negative 16 minus 16R equals 84 minus 84 over R. So all I got to do now is try to solve this for R. You'll notice I got a negative 16 and an 84, so I can go ahead and put those two together by adding 16 on both sides. And the problem I have is I've got this R in the denominator, and so I want to get rid of that. So I'm going to multiply everything times R. So that's going to give me negative 16R squared is equal to 100R, and now it's just going to be minus 84. Now it's a quadratic, so I'm going to add 16R squared to both sides and make it equal to 0. And then I can either use a quadratic formula or try factoring it. In this case, it divides by 4. And if you factor this out, you're going to get negative 84 and 25. I need to find two numbers that multiply to negative 84 and subtract to get 25. Well, with a little guessing and checking, you'll find out that it's 3 and 28. They have to be pretty far apart because there are 25 between them. And so then that means R has got to equal 3/4, or R has got to equal negative 7. Well, keep in mind in the problem, they told us very specifically that all the numbers in the progression had to be positive, so my R cannot be negative. So now I know what R is. That's 3/4. So all I got to do now is plug in the 3/4 into one of the equations I have and figure out what X is, the second term. So that's going to be 84 over 1.75. That's going to give me a second term of 48. And see, now all I got to do is take 48 and divide by the common ratio, which is 0.75, and that's going to give me 64 for the first term. So I've got the first term, and that's all I got to do. So I hope that helped. That was a rough one. Thanks for watching.